Hello and welcome back to the Data Unite channel. My name is Ceko and today we will discuss about the naive Bayes machine learning model. If you like this kind of content and you want to learn more about machine learning, please make sure that you like this video and subscribe to the channel. Naive Bayes classifiers is a supervised machine learning algorithm that is used in classification problem. It is a collection of classification algorithms based on the Bayes theorem, which share a common principle. That is, every pair of features that are being classified is independent of each other. When applying this algorithm, we have to keep in mind the following assumptions. All the features used to determine the class are independent, and the features have an equal contribution to the outcome. Examples of problems that can be solved with the naive Bayes classifiers are sentiment analysis of a sentence, spam email classification, document categorization. It is also used frequently in natural language processing, like for example chatbot projects. As any other algorithm, there are advantages and disadvantages when implementing it. And advantages for implementing naive Bayes model are: works well with a large amount of features. It also works well with large training data sets, because in that way the model has enough data to be trained pretty well and to perform well. Convergence is quite fast, which means that it ends the training in very short time. Performs well with categorical features where we have distinct values and we don't have to scale the features. Also, missing values and outliers do not impact the outcome since they can be ignored by the model. But a big disadvantage is that if we have independent features that are correlated, that will impact the performance of the model, and those features should be managed by removing one or both of them from the dataset. Since we are talking about naive Bayes model, that means that it applies the Bayes theorem. And there are two types of events: independent events that don't impact on each other's outcomes, like for example a coin toss event or a dice roll event, and dependent events where one event's outcome depends on the outcome of another event. For example, drawing cards from a card deck without replacement of the card after drawing it. So the Bayes theorem calculates the probability of an event A occurring, knowing that the probability of another event B that has already occurred. This means that event A depends on event B, so A is a dependent event and B is an independent event. And this type of event is also known as evidence. The general formula for the Bayes theorem is probability of having event A given that event B occurred equals to the probability of event B given A multiplied by the probability of event A and all of it divided by the probability of event B. So if we want to implement the Bayes formula on a machine learning problem, that means that as independent variables we will take all the features in the dataset that are represented as X and are going to be used in order to calculate Y, which is the dependent feature. And as you can see in the formula for calculation of the posteriori probability, at the end we have the probability of the dependent feature multiplied by the product of the likelihood for each independent variable and divided by the product of the probabilities of all the independent variables. Because the denominator is consisted of the probabilities of all independent variables, we can count it as a constant and we will use just the numerator in the formula, where we will look for the maximum value, since we know that if the numerator is bigger, we will have higher result in the equation and hence we will have higher probability for the dependent variable Y. So for example, if for the class yes we have a probability of 0.8 and for the class no, we have the probability of 0.2, the outcome from our calculation, so our algorithm, will take in consideration the one that is higher. So it will classify the value in the variable y to the class yes, because the probability was higher, which was equal to 0.8. With this, we have covered the theoretical part regarding the naive Bayes algorithm, and in the next video we will see how we can implement it on a real-life classification problem. Thank you very much for watching this video until the end, and see you in the next one. Bye bye.